In this video, I'm going to tell you about types of motion. So, uh, we are just dealing with motion in a straight line, and therefore, we can divide motion into two categories only. One is uniform motion, and other is non-uniform motion. All right, so in uniform motion, remember velocity remains same, and in non-uniform motion, velocity is not constant. It changes in non-uniform motion. All right, so so far what we have studied about uh, average speed, average velocity, but we haven't discussed about a varying speed. There were some questions in which there were two or three different type of speeds in a same question, but that was constant for over a period of time. That was not increasing or decreasing um, mm, in a proper order. So there were some discrete values that earlier speed was this and suddenly speed is this and suddenly speed is that. It was not like that speed is increasing from 5 meter per second, then it became 6, 7, 8, and then it became 10. It was not like that. So if speed is or velocity is constant, now I'm going to use the term velocity only. Velocity, that is because we are dealing with motion in a straight line. So if we are dealing with that concept, then we would be dealing with the displacements, and hence we are interested in velocity more. So most of the time in NCERT books also there are some questions in which they will give you the term that an object traveled a distance so and so, and they are not mentioning in which path the object is moving. Then you have to assume that it is a straight path, and then you have to say that okay, now we are interested in displacement, then consider that distance as displacement and consider that speed as velocity. So be careful about this. So if velocity is constant, then motion is uniform, and if velocity is changing, then motion is non-uniform. Remember that. Actually we have to say speed, but right now we are dealing with a straight line. Then uh, magnitude wise, numeric value wise, both are same. Okay, so uh, what if velocity is changing? Which way velocity is changing? Is it suddenly going from 5 meter per second to 10? There's no values in between. It is not going like 5.1, 5.2 and then reaching to 10 meter per second. So if that thing is happening, then it is non-uniform motion. In the vehicles, there is a pedal, there is a component of that vehicle which is called accelerator. What does an accelerator do? It does acceleration, which is which means increase in the speed. But here we use it very technically, and it is not always used as increase in velocity, but it it refers to a change in velocity. So an acceleration is another physical quantity which we have to understand, but right now I'm not explaining it. I'm just using that term here. For uniform motion, acceleration, its symbol is a, and remember it is small a. It should be written in lowercase only. So acceleration is 0 for uniform motion, and for non-uniform motion, acceleration is not 0. Another important thing here is, in fact, this non-uniform motion can further be divided into two categories. First, non-uniform motion, with uniform acceleration. Uniform acceleration means acceleration is constant. There is acceleration, there is a cause to change the velocity, but it is constant. It's not changing itself. And it is non-uniform motion with changing acceleration, varying acceleration. Means here acceleration is not constant. It is also changing. Maybe it is fluctuating, maybe it is increasing, but acceleration is not constant. For this case, for uniform motion, we use this formula: velocity equal to displacement upon time, and that's all. Nothing else we require. Maybe for displacement we'll cross multiply, for time we will further cross multiply. That's all. Nothing more is required. But for non-uniform motion with constant acceleration, because velocity is changing, which velocity will we put in this formula? We'll put average velocity. How we'll find average velocity? So there we use equations of motion. And what are we going to do here? What are equations of motion? It is a set of 3 equations, and I'm just mentioning them here, and I will explain it in next video. So there are 3 equations: v equal to u plus at. A is that acceleration which I was talking about. V final velocity, because there are 2 velocities now. This is final velocity, this is initial velocity, starting and ending. T is time. S equal to, S is not speed, it is displacement. S equal to ut plus half at square. This is second equation of motion. And third, v square equal to u square plus 2as. Remember, u is initial velocity, v is final velocity, s is displacement, a is acceleration, and t is time, we know. So what are the examples of uniform motion and non-uniform motion? And in fact, non-uniform motion with constant acceleration, non-uniform motion with varying acceleration. So first thing, uniform motion, like light in vacuum. Speed of light is constant in vacuum. In a medium it changes, but within that medium still it is constant. So that is one of the cases. Other, we can say a car moving in a straight highway with constant speed. Yeah, of course. A train moving in a moving with constant speed. Yes, of course. So whenever we have to give some example of uniform motion, we can give such examples by saying that this particular object is moving with constant speed. That is the condition, that is the example of uniform motion. Non-uniform motion with constant acceleration. A car speeding up, that is the case of constant acceleration. The best example of non-uniform motion with constant acceleration is motion under gravity. If we drop something, its speed increases. If I want to hold it here, its speed is negligible. But here it is increasing. It has increased so much. So if you drop something from your table, it will not acquire that much speed when it reaches ground than if you drop it from the top of the building. So why? Because there is an acceleration due to gravity, due to gravitational pull, and due to which um, speed of the object continuously increases. So if you want to give some if you are asked to give some examples of non-uniform motion with constant acceleration, the best example is motion under gravity, a freely falling body on Earth, on Moon, on any other planet. Okay, non-uniform motion with varying acceleration. This one is tricky. So you can say a vehicle in a crowded region, or a leaf uh, falling in a stormy condition, storm, speed of storm, objects moving in a stormy condition, objects flowing in a flooding river. So or a surfer surfing during tides. So these are some of the examples of non-uniform motion with non-uniform acceleration. So now in the next video we are going to um, understand the concept of motion with the help of graph and with the help of some mathematical formulations.